In this exercise, we consider a Burr-distributed random variable x with parameters alpha, gamma, and theta, and a Pareto-distributed random variable y with parameters beta and lambda. Let z be a mixture of x and y with equal weight on each component. We're then asked to determine the median m of z for alpha and beta equal to 1, gamma equal to 2, and theta squared equal to lambda. We also consider w, which is equal to delta times z. We then need to demonstrate that w is a mixture of a Burr and a Pareto distribution, and we need to determine the parameters of w. In the first part of the exercise, we will start with the median m of z. Now, the random variable z is a mixture of the random variables x and y with equal weight on each component. So this means that the cumulative distribution function of z is the weighted sum of the cumulative distribution functions of x and y, where the weights are equal to 1 over 2. Now, x is a Burr distribution and y is a Pareto distribution, so we can fill in these cumulative distribution functions, and these can be found in the appendix of the book. Now, the median m of z is determined in such a way that the cumulative function of z evaluated in the value m is equal to 1 over 2. Now, given are the following values for parameters of both distributions, so we can fill this in to get the following expression of our cumulative distribution function of z evaluated in m. Now we have 1 over 2 on this side and 1 over 2 here and here. So in the next step, we will multiply both sides by 2. Here we have 2. So we can bring them to the other side and we get minus 1 here. And here we have minuses, so we can multiply everything with minus 1 to get rid of them, which results in the following expression. Now we need to find an expression for m. So in the first step, we'll convert everything to the same denominator. We will then multiply both sides by the common denominator. We then rewrite both sides as follows. We can delete the common parts, which then finally results in m equal to lambda to the power 2 divided by 3. In the second part of this exercise, we concentrate on the random variable w, which is equal to delta times z, where delta is a strictly positive number. Now, in order to demonstrate that x is a mixture of a Burr and a Pareto distribution, we look at the cumulative density function of w evaluated in a number small w. Now, this is equal to the probability that capital W is smaller than or equal to small w. We can replace the capital W with delta times z. And as delta is a strictly positive number, we can multiply both sides by delta to the power minus 1 to get the probability that z is smaller than or equal to w times delta to the power minus 1. Now, an expression for this cumulative distribution function of z we already found in the first part, and this was equal to the following one. Now here we have delta to the minus 1, so we multiply both numerator and denominator with delta, and here we also have delta to the power minus 1, so we do the same. And then we get the following expression. On the left side, we recognize the cumulative distribution function of a Burr distributed random variable with parameters alpha, gamma, and theta times delta. So not just theta, but theta times delta. On the right hand side, we recognize a cumulative distribution function of a Pareto distributed random variables with parameter beta and lambda times delta. So not just lambda, but lambda times delta. So as a conclusion, we can say that a W follows a mixture of a Burr distribution with parameters alpha, gamma, and theta times the delta, and a Pareto distribution with parameters beta and lambda times delta, where the weights are again 1/2. So a 50-50 mixture. And this concludes the exercise.